We are working with the aldehydes and ketones for part 3 of the experiment. The functional group for aldehyde, CO double bond attached to hydrogen on one side, carbon to the other side. So the carbonyl group carries a hydrogen compound. Hydrogen group attached to it. And for ketone, you have a CO double bond attached to 2 alkyl groups. That gives like specific reactions that aldehydes can go through and ketones cannot. There are also some common reactions that both aldehydes and ketones, they both can go through because they both have carbonyl groups. For qualitative analysis, in order to identify an unknown, first of all, we want to make sure that this compound, the unknown or the compound of our interest, it is either aldehyde or ketone. And can you tell me which test is going to confirm that your compound is either aldehyde or ketone? Which classification test? Which classification test you can use to find out your compound is either aldehyde or ketone? Both aldehyde and ketone would give positive tests with it. So Iodiform Test, Toluene Test, today, those are part of the experiment. They are part of the experiment, and based on the experiment, based on those, we can identify if the compound is aldehyde or ketone, or if it's a methyl ketone. But you must have a reaction that would give you, no, none is correct actually. Because those are, it's not, my question is, you have to have a test that both aldehyde and ketone would give positive test result. If you do toluene reagent, you use toluene reagents. For toluene reagent, you only get the aldehyde being oxidized to carboxylate, and then you get your silver precipitate. Basically, silver is going to be reduced, so it's only aldehyde that gives the positive test. So I don't have the answer yet. I'm waiting for the answer. So what would be the test that both of them would actually give positive results, positive test results? Okay. When you use 2,4-dinitrophenylhydrazine, 2,4-dinitrophenylhydrazine, you have the chemical equation here. So for the 2,4-dinitrophenylhydrazine, it's on page 206 for the hardcover and 204 for the ebook. So you have that equation. 2,4-dinitrophenylhydrazine is going to give you yellow precipitate for both aldehyde and ketone. So if your compound gives the positive test, then you are sure it's either aldehyde or ketone. Then on the next steps, you want to know, is it aldehyde or is it ketone? If it's aldehyde, it's going to give positive tests with toluenes, because toluene is the oxidizing agent. You can oxidize aldehyde, but you cannot oxidize ketone any further, because ketone doesn't have any hydrogen attached to the carbonyl carbon. So toluene reagent would be 1. Your equation is on page 207. On page 207, you do have the equation that is aldehyde with the toluene reagent is going to be oxidized to the carboxyl group, and is going to, the silver is going to precipitate, and the silver is going to give you silver mirror. So if your unknown with toluene reagent gives a positive test, that means formation of the silver mirror. That's indication for your compound being aldehyde and not ketone. The other test that we are going to do today is the Iodiform Test. Now, Iodiform Test, we performed Iodiform Test before, but that was for a methyl alcohol. The Iodiform Test that we are performing today, this is for methyl ketones. So one side of the carbonyl group is, one side of the carbonyl group is a CH3. So if you have a methyl ketone with the iodide solution, is going to give you iodoform, and as a yellow, you get yellow precipitate, and with the yellow precipitate forms, that means that if your compound was not aldehyde and it was ketone, now if your ketone gives positive test with iodoform, that means your ketone is methyl ketone. So if your ketone is proven to be methyl ketone, you are one step closer to identifying or giving a structure formula for your compound. So if you know you have ketone already, knowing that your ketone is a methyl ketone, like if you have hexanone, is it going to be 2 hexanone, or it could be 3 hexanone, 4 hexanone? Is going to be different than the if you have like 2 hexanone. So when you say 2 hexanone, that means the CO double bond is on carbon number 2, and that means you have a methyl ketone. So basically you narrow down your choices. So you narrow down your choices in order to find out. We are getting one step closer to identifying the structure formula for the compound. Okay. The next test, it would be chromic acid test. Can you tell me if the chromic acid test is positive, what is the conclusion? What would be the conclusion, or what is showing if the chromic acid test is positive? Remember, I'm sorry. Remember, we are only working with aldehydes and ketones. So your compound is either aldehyde or ketone. And if the chromic acid is positive, that means your compound is going to be aldehyde and not ketone. So if the compound is aldehyde, you're going to get the aldehyde oxidized using chromic acid, because chromic acid also is a strong oxidizing agent. Is going to oxidize the aldehyde, but chromic acid is not going to oxidize ketone. So if the test result is negative, that means your compound is ketone. If the test is positive with chromic acid test, means your compound is aldehyde. There's another reagent also known as the Schiff's reagent or Schiff test. With the Schiff test, we are going to come to the same conclusion, because Schiff reagent also is a strong oxidizing agent. And the strong oxidizing agent, it can only oxidize aldehyde, not ketone. If the test result is positive, that shows presence of aldehyde. If it's negative, that means your compound is not aldehyde. So it could be the ketone. Okay, the chart on page 210. If you learn about this chart, is like a picture, says 1,000 words. It's the same thing, or shows 1,000 words. With the chart, like if you're starting with the set of the 6 chemicals that is given in the box, if those compounds They dissolve in sodium hydroxide. That means they are carboxylic acid. They don't dissolve in the sodium hydroxide. That means they could be aldehyde or ketone. If it's aldehyde or ketone, they would be confirmed by formation of the precipitate with 2,4-dinitrophenylhydrazine. And with the 2,4-dinitrophenylhydrazine, if it is positive, then it's aldehyde or ketone. Now, if you have you don't know if it's aldehyde or ketone, then you would do either one of the tests for oxidation. Either you would use the Tollens reagent, you would use chromic acid, or you would use the Schiff reagent to see if it's aldehyde or ketone. And then you would confirm that your compound is which functional group. Because when you do solubility test, and when we looked at the solubility chart, which is on page 183, again, correction, 181 for the ebook, when you use the chart, if the compound is not dissolved in sodium hydroxide, is not dissolved in HCl, it dissolves for sulfuric acid, then you get a group of the compounds. So you're not getting group of different families. You are not getting one specific functional group. So if it dissolves in the sulfuric acid, that means you had to go all the way down to dissolve in sulfuric acid. That means it was not dissolved. It did not dissolve in water. It didn't dissolve in sodium hydroxide. It didn't dissolve in HCl. Then you tried the sulfuric acid. So when it dissolves in sulfuric acid, that could be alkene. It could be alkyne. It could be high molecular weight alcohol. It could be high molecular weight aldehyde. It could be high molecular weight ketone, and everything else that is in this box that it says soluble. So it could be ester, it could be ether, and it could be any polar compound containing oxygen. So we cannot leave the compound with predicting that it could be this or that or the other one. We have to do classification tests and identify what is it then. So from the solubility, you narrow down. It was page 183 in the hard copy, and that was group Z that I was talking about. So if you narrow down your unknown or your compound to be one of 5 or one of 4 possible functional group, you have not identified your compound. So what you need to do, you need to narrow down using classification tests. So if you think your compound is group Z because it did dissolve in H2SO4, first you have to make sure you eliminate alcohol. How would you eliminate alcohol? How would you know your compound is not alcohol? Can you tell me, how would you find out it's not alcohol? Which test? Which test are you going to use? Which test you would use to find out your compound is not? Steric nitrate, very good. So you would do steric nitrate test. If it doesn't give you like a red color, that means that your compound is not alcohol. How would you know you have aldehyde or ketone? You could do 2,4-dinitrophenylhydrazine, and then you know it's either aldehyde or ketone. Now, how would you know it's not aldehyde and it is ketone? How would you find out that it's not aldehyde, but it is ketone? So if both of them is a possibility, it could be aldehyde or ketone. How would you know it's not aldehyde? You could do chromic acid test. You could do tolerance tests. Either one of them is going to be negative. And if it's negative, then you know that is not aldehyde, so it is ketone. How do you know your compound is methyl ketone or it is not methyl ketone? Then you do iodoform test. So let's say you do iodoform test, and then from the iodoform test, you find out that it's positive. Now, you know your compound is a methyl ketone. But there could be plenty of methyl ketone. You could have 2-butanone, 2-pentanone, 2-hexanone, acetophenone. They're all methyl ketone. That means they have a methyl group attached to the carbonyl group. How would you find out which methyl ketone you're talking about? Then your compound, if it's solid, you take a melting point and compare to the table that you have for ketones with ketones that are solid at room temperature. So if you have ketones that are solid at room temperature, you are going to use the table that shows physical property for ketones that are solid at room temperature. You find the melting point, and then from the chart, you can match the melting point with the melting point of the compounds you have on this table. And if it happens to be a methyl ketone, that is a great chance that that would be your compound. And if the melting point is too close, then you have to do derivatization. And derivatization is like changing the compound to the functional group. But since your base compound is known, just like what you did in experiment 12, then you can map it back to original compound. We have many choices for a few choices for derivatization. Then for derivatization, we have to pick properly which derivatized compound we are going to use. So in order to pick the proper derivatized compound, we have to look at different columns and see, we have to have a number. If hypothetically, let's say if I have a number that is, let's say if the melting point is 78, okay, if the melting point is 78 on that page 233, if the melting point is 78, then with the 78, it could be nitroacetophenone, or it could be like parachlorobenzophenone. So you have two choices with that 78, two compounds very close to that. And because you have two compounds very close to it, then you could do the dinitro compound, the phenyletrazine of that compound. So basically you get your unknown, you mix it with phenyletrazine, and then you get a precipitate. You dry that precipitate, you measure the melting point, and from the melting point you find out if it's 185, then it's going to be chlorobenzophenone, and if it's 228, it's going to be nitroacetophenone. So you can use the chart to decide how you pitch derivative you should pick and which reagent you should add. So the first step of identification obviously is determining the solubility, because you don't want to deal with every functional group. You want to narrow down your unknown. You narrow down your choices to find your unknown. So when you do solubility chart, you follow the solubility chart and you test for solubility. You can decide your compound is carboxylic acid. Is it amine? Is it? It could be ketone, aldehyde, or alcohol, or it could be like aromatic compound that it's hydrocarbons that are not polar, that is not going to dissolve in sulfuric acid. Then you do classification tests, and each classification test is different for eliminating choices again. Like for steric nitric is going to eliminate your compound. It's not alcohol. If you don't get like a brown color, you know your compound is not phenol. Then you could do DNP. DNP, it can give you answer if your compound contains carbonyl group or not. So it's going to eliminate your choices. So you can find out what your compound is at the end. But the final answer, we need to get the for the final answer, you need to get the actual name for the compound, okay, for the final answer. There is a question, should we submit like 3 separate reports? You didn't have reports for 17 and 18. You are not going to have report for 20. Then for this one, yes, because I ask you one report only. And then I also have some students, not many, but I do have maybe 1 or 2 students every semester. And it may not be your class, that they give me like 1 page or page and a half report with like 2 lines of abstract, 3 lines of introduction, and then a very short conclusion. And if I ask that for 3 experiments combined and I get similar report, it would be very hard for me to grade and judge understanding of the experiment. So please, yes, separate reports. And since these reports are going to be the last reports and they are due on Sunday, if needed, I can extend the date to like Monday or Tuesday for you. This way, you have more time to submit it and separate. Okay, I'm going to make it to due by 12:30 on Tuesday then. Okay, 12:30 on Tuesday. You're welcome. Okay, we have to do experiment because it's not just the theory, so we have to go ahead and do the experiment now, so you could see how it's going to look like the evidence for the reactions. You have to train your eyes to look at the evidence for the reaction. If it's going to be aldehyde, is going to be ketone based on the result of the experiment. So for the procedure, I'm going to end on you telling me what should I start with, which experiment, which test I should start with. Please write down in the chat area what would be the first step. So the first step for this experiment, part 3 of the experiment 19. Tell me which experiment should I do first? Two,4-dinitrile, and I have to pick I'm going to have to pick the unknowns, and I have going to make sure I have some written chapter blocks. How many aldehydes and ketones we have? Okay. If I have everything. So I would do one experiment at a time, so you record your observation. One chemical at a time. What's the quantity procedure? Four to 5 drops of the liquid and 1 milliliter of the DNP. So we have our DNP reagent here. Going to The NP reagent is orange color, but it is clear, so it's not cloudy. The positive test is not the color, it's the texture. So we have to make sure that we are getting the precipitate for it. So the first compound is cyclohexanone. 5 drops of cyclohexanone. And adding the dinitro, 2,4-dinitrophenylhydrazine. It changes to a yellow color precipitate. This precipitate is actually the derivative of this aldehyde or ketone in this case. I can wash this, I can filter it, wash it, dry it, and make this my sample for derivatization. So if I don't discard this, like when I'm working with the unknown, if I don't discard this, this is already the powder is the precipitate of the 2,4-dinitrophenylhydrazine plus my ketone. So if I filter it and dry it, I can use this for my unknown melting point, for derivatization of the melting point. So it's very helpful to save it. Now, did you record the positive test for it? Well, they would all be positive, but we just want to make sure that you see they're not all the same shade of the yellow or orange color. They could be different. Next one is acetophenone. I'm going to use the acetophenone as my next sample. 5%. That's acetophenone as a cyclohexanone. The shade of the color is not exact the same, but both of them produces precipitate. So I can use the precipitate for melting point later after I get it. And it's the evidence that the compound is either aldehyde or ketone. And one aldehyde. Butyraldehyde is very small. You won't be able to see it, but I'm just showing the label in case you can see. Butyraldehyde plus the DNP. That's the positive test for it. Acetophenone. The orange one was, the second one was acetophenone. And this is the aldehyde, butyraldehyde. So we are working with 3 compounds. One cyclic ketone, and one aryl ketone, and one aldehyde. So it's the cyclohexanone, acetophenone, and butyraldehyde. 3 compounds. All of them are positive, yes. You mix them all separately in separate test tube with the 2,4-dinitro. The precipitate is the positive color, not the color. Okay, is the precipitate that is going to give you the positive test. What's the next test? Tolerance reagent. Okay, for tolerance reagents, We already talked the reaction is an oxidation reduction type reaction. In this case, I have to make the reagent first. I have to make my toluene reagent first, and to make the toluene reagent, I'm going to use the silver nitrate, sodium hydroxide, silver nitrate. How many drops? 2 milliliters. Okay. So 2 milliliter is like 40 drops, about 40 drops. I'm going to make it all in one test tube and then divide into different test tubes for the compounds. I'm going to test with the 3 separate compounds. When I add the sodium hydroxide, I get yellow color precipitate. I'm sorry, not the yellow color. A gray-brown precipitate. What should I add now to make a toluene reagent? What do I need to add? This is not the toluene reagent yet. What should I add to make it toluene reagent? You have your steps in your lab notes book by any chance? It's probably easier to find it there because you wrote it. Add ammonium hydroxide. Okay, add ammonium hydroxide. How much ammonium hydroxide should I add? Can you tell me how much ammonium hydroxide should I add? Dropwise until the precipitate dissolves. Very good. Okay. Okay, the precipitate dissolved in the basic solution with the presence of ammonia. In ammonia solution, the precipitate dissolved. Now, I'm going to divide this in 3 so I can test my 3 compounds. So we bring the test tubes. Silver nitrate, it can stain your skin, and if it does stain, you can't wash it. It will stay there for like 2-3 weeks until the skin is peeled off. So when you're working, if you're working with the silver nitrate, you have to be very careful so it doesn't contact your skin. So I'm going to divide this into 3. I have my tolerance reagents ready, and in 3 separate test tubes. To the first one, I'm adding cyclohexanol. How much cyclohexanol should I add? How much of the aldehyde or ketone should I add? How many drops? Acetophenone. butyraldehyde. Okay. The compounds. Do you see? Can you take a screenshot of them by any chance? I can bring them closer, but I'm risking the computer, but I'm going to bring it closer. Okay. Okay. Do you see it now? Take a screenshot. Okay. Did you notice formation of the silver mirror? Yes, for test tube 3 only, because these two are ketone and only this one is aldehyde. Only aldehyde would give positive test, ketone will give negative test. A black precipitate or silver mirror is the indication your compound is aldehyde. Okay, I hope you all took your screenshot. We need to wash these with acid right away with because you don't want to do the toluene reagent. If it dries out, it changes to explosive compound and is not safe. So I'm going to take care of washing of this part first before I continue with the rest of the experiment. Okay? I'm going to use some acid to wash them first. Okay, you record the evidence for toluene reagents. What is next test? Iodiform test. Should I test for aldehyde or should I test for ketones only? Iodiform test goes for ketone only. We want to know if it's methyl ketone or it's not methyl ketone. So I'm going to test it to two compounds only, two of the ketones. One is the acetophenone and the other one is the cyclohexanone, and look for the difference. What is the procedure? We did this experiment before together, right? For alcohol. What is the procedure? Okay, perfect. So I'm going to work only with the cyclohexanone first. Cyclohexanone 5 drops. Then I'm adding 2 milliliters of water, about 2 milliliters of water to dissolve. Next, what was the next step? Was toluene acetophenone insoluble? What does it mean? This is the cyclohexanone. That's the cyclohexanone. We're adding the glycine or 2,1,2-dimethoxyethane to dissolve it, to make sure that it's dissolved. Okay. And when it's dissolved, what's next? Okay, it's dissolved. It dissolved already. What should I do next? Okay. You can check probably for the toluene, you took the screenshot. Please use the screenshot for that because you could see the evidence is not the precipitate or not precipitate. For toluene reagent is the silver mirror that is going to form or not. Okay. Okay. So we add sodium hydroxide. Is it still pause or no? So we are going to add the sodium hydroxide. And after the sodium hydroxide, we are adding the iodine solution, the KI2. With the iodine solution, no precipitate has formed yet. What should I do? I need to add more of the iodine solution until the color stays there. It has to be yellow color before I let it stand. Well, I know cyclohexanone is not methyl ketone and is not going to form. I just want to make sure that if it's an unknown, we know how it looks like for negative test results. So you keep adding iodine and no precipitate forms. The color is now stable. So I don't have to add any more iodine. I can record negative test for iodoform. Negative result for the iodoform, okay? And it makes sense because cyclohexanone is not a methyl ketone. I add enough iodine because the color is safe. Now, repeat the same experiment for acetophenone. So 5 drops of acetophenone about 2 milliliters of water, making sure that it dissolves. And since it doesn't dissolve, we are going to add dimethoxy for it to dissolve. Going to add sodium hydroxide, since it's the same experiment. Okay, since it's the same experiment, I'm just repeating the same steps. I add a sodium hydroxide, 10% sodium hydroxide, to make the solution basic. Okay. Okay. Okay, it dissolved. I have clear solution up here. It dissolved. Now I can add the iodine solution. Okay, it completely dissolved. I can add the iodine solution. When I add the iodine solution, 10 drops. Mix it well. Lower the volume. Iodine solution. Do you see the cloudy? The particle that makes it cloudy, it forms as I'm adding iodine. It gives yellow color precipitate. Okay, a cloudy solution, like cloudy, and that gives yellow color precipitate, which is formation of the iodide or iodoform with iodine and the acetophenone. Also going to try with the acetone. Acetone is probably much faster. Formation of the acetone is going to be much faster. Acetone is and water. This one doesn't need lime because it's already see the yellow color? A positive test for iodoform. So I want you to take a screenshot of this too. Negative test for iodoform, that's the color that you should have at the end. Positive test for iodoform. This means your compound is methyl ketone. Cyclohexanone is a non-methyl ketone. It's not the yellow that is negative. It's the clear that is negative. No precipitate, that means it's negative. Okay? No precipitate, that means negative. Precipitate formation of a yellow color precipitate is positive. So it's the texture, is not the color. This one is clear, but still yellow color. And then this one is the yellow color precipitate. Okay, the positive test actually was for acetone. Okay, acetone was positive, cyclohexanone was negative. Cyclohexanone and acetone. Acetophenone did not form precipitate. I'm going to leave it and wait for 15 minutes because this wasn't giving me precipitate, and I wanted to show you how the positive test looks like. I used acetone because I know acetone is, this one is acetophenone. This is acetophenone. Acetone is this one. Acetone. And cyclohexanone. I'm waiting for the result for acetophenone. I'm going to let it stand, come back to it at the end of the lab. It didn't form. I didn't see the precipitate, so just going to have to wait for the acetophenone, see what happened with the acetophenone. Maybe I have to mix it well and wait longer, but it didn't form. Okay. Next test. What's next experiment? Chromic acid test. Chromic acid test for aldehydes and ketones. Okay. The test tubes. 1, 2. I have 2 test tubes here and 3. What is the procedure? Adding cyclohexanone, acetophenone, and butyral. Going to let you take a picture like this with the test tubes on top so you see the difference. What's the next step? Add 5 drops of chromic acid. Okay. Oops. Can look at the color of the chromic acid before being added to any of the chemicals, because you want to have a reference color. This is the color. If there is no reaction, the color is going to stay. If there is a reaction, the orange color of chromic acid is going to change to yellow, to green color, and you would see like shade of a green color in the test tube. So I'm going to add chromic acid. And I'm holding it like this with the labels, so you know which one is which, because at least you can go back and check the colors and check the labels. Okay. Take a screenshot. Just want to make sure it's in the level you could see. Yeah, you have your screenshot? Okay, good. Which one is positive? Which one is positive? Which one is negative? Butyraldehyde is the only one that is positive because the color has changed. The ketones did not change color, stay the same color, and is not being oxidized. So, okay. The shift reagent is not out. I think we have it, but it's not out here. At the same time, I don't think we need the shift reagent because we already had the toluene test and the chromic acid test, and both of them confirmed that only aldehyde can be oxidized and the ketones cannot be oxidized. Okay. Any questions? I didn't have to dissolve it. They were, I added directly. Yes, I added directly to the chemicals because the chromic acid is the aqueous solution itself. Sometimes when we dilute, we get less of the color change. The color change is not significant. It makes it hard. So I just added directly. Because for alcohols, when I added directly, it worked better. Let's see what this is saying. Have any questions for me? The color change, if you look at the screenshot, the last screenshot that you took, you notice the color change, yes. Any questions about the experiment today? Please, yes, because that was the color. You saw the precipitate actually, and the other one, the acetophenone. Let me see if it even reacted. The acetophenone did not show precipitate. I have to search into this to see why acetophenone is not giving me precipitate. This acetophenone has a methyl and a phenyl group attached to CO double bond. Maybe with the aromatic ketone is not showing, or the reaction is much slower, and sometimes it requires heat. So make sure you report the acetone for the iodoform test for positive. I don't have the reagent for the shift test. The reagent is not here. We don't have the reagent. That's why I had to skip it. But the result would be very similar to the chromic test, very similar. We usually have like two methods in case the lab doesn't have one of the reagent, you can use the other one. But since we already had the toluene and we had the chromic acid reagent, we are fine. The purpose of that is just to find out if you have aldehyde or ketone. If you can already decide is aldehyde or ketone using toluene reagent and using the chromic acid reagent, you should be fine, believe me. You already confirmed, and both of them are valid tests. Questions? I'm just going to move it that way so I can plug in the computer before it stops. You have lab tomorrow, right? We have lab tomorrow at 12:30. And that would be for carboxylic acids. It would be carboxylic acid and amines. I might go over, I might have also a review for the, most likely, it's going to be a review for exam also. But I want you to take your exam after you do first part of the unknown. We do the first part of the unknown, which is solubility test. Okay. If you don't have questions, I'm going to stop the recording because I'm going to call for attendance and answer your questions. Let me first stop the recording.